Welcome to this example on solving a problem with a multi-step problem with fractions. We've got 5 halves times 1/3 plus 2/5 times 2/3. So we've got a multi-step problem to do here. First thing you should notice is you've got multiplication and addition here, and it is important which one you do first. When you have multiplication and addition, you always do the multiplication first. And if you want to learn more about that, you should check on the order of operations and look that up. You might talk about that more in a future video. But for right now, with multiplication and addition, we always do the multiplication first. So the first thing that we're going to do is we're going to multiply 5 halves times 1/3. And then we're going to bring the plus sign down, and we're going to come over here and we're going to multiply 2/5 times 2/3. When you're multiplying fractions, it's pretty straightforward. You're just going to multiply the numerators together. 1 times 5, or 5 times 1 is 5, over, and for the denominator we have 2 times 3, which is 6. That's all you got to do. Bring down the plus, and we're going to do the same thing over here. Now, for those of you that have maybe done some multiplying before, or remember, you can cancel when you're multiplying fractions. Any factor, common factor, with the numerator and the denominator, but we don't have that here. We have 2's in our numerator, and 2 does not go into 5 or 3. In the first part, we had a 5 in our numerator, and nothing can cancel with that 5. So this problem doesn't have canceling, but it is something good to look out for. Alright, so for our second multiply problem, we have 2 times 2, which is 4, and 5 times 3, which is 15. Alright, we got that done. So now we've got to do our addition. And when you're adding fractions, you have to have a common denominator. So this number here, this 6 and this 15, they have to be the same number, which they're not. So we have to make them the same number. And the way that we figure out what number we want to use is we have to think of a number that 6 and 15 both go into, preferably the smallest number they both go into. The way I like to do this, and there's a couple ways to do it, is I like to take my biggest denominator, which in this case is 15, and I like to ask myself, does 6 go into 15? Which it doesn't. So then I go to the next multiple of 15, which is 30. And I say, does 6 go into 30? And it does. So that's what I'm going to use for my least common denominators, 30. So I'm going to jot that down to remind myself. Oops, least common denominator, which is 30. Kind of messed up that C there. That's okay. So I need to make this 6 and this 15 into a 30 by multiplying. 6 times what is 30? Well, that would be 5. So I need to multiply this denominator by 5 to make that a 30. The thing is, though, if I just multiply the denominator by 30, I'm going to change the value of this fraction. I don't want to do that. So I have to multiply the top by 5 as well. So what I'm essentially doing is I'm multiplying by 5 over 5, which is worth 1. And we all know that 1 times anything is just that same amount. So when I multiply by 5 over 5, 5 times 5 is 25. 5 times 6 is 30. I get this new fraction, 25/30. And the thing is, 25/30 is actually the same exact amount as 5/6. If you ate 5/6 of a pizza, or you ate 25/30 of a pizza, you'd be eating the same amount of pizza. These slices would be bigger, and you'd have 5 slices, and these slices would be tiny, but you'd be eating 25 of them, and you'd be ending up with the same amount of calories. So that's important. We haven't changed the value of this fraction, we've just changed how it looks. Okay, so we're going to go and we're going to do the same thing with 4/15. And in order for the 15 to become a 30, I'm going to have to multiply by 2. So I'm going to multiply both the numerator and the denominator by 2, doing the same idea. 2 over 2 is 1. 4/15 times 1 is just 4/15, some other version of 4/15. 4 times 2 is 8. 15 times 2 is 30. So 4/15, that's the same as 8/30. It's the same amount. So why did I do all that multiplying? Well, I wanted to get these denominators to be the same. They're both 30ths now. They're the same size of slice, so I can add them together. And when we add fractions, we add the numerators. 25 plus 8 is 33. And the denominators we keep the same because that's sort of like the size of your slice. So we've got 33 slices that are 1/30th of the pizza. They're pretty tiny. I keep using pizza, but you could use other examples as well. Well, I notice here I'm pretty much done, except my numerator is larger than my denominator. That's called an improper fraction, and we usually like to write those as mixed numbers. And we do that by dividing. Remember, fraction bar can always be thought of as division. 33 divided by 30. 30 goes into 33 one time, so that's going to be my whole number part. And how many left over? Let's see, that would be 3 left over. So that's the numerator, over, and then you keep the denominator the same, which is 30. So 33/30ths is the same as 1 whole, and 3/30ths, and that is going to be my final answer. Well, I hope this video helped.